Right, question 22 this is actually on the 6 to 8 paper now. This is testing your knowledge about averages, median and mean. Particularly what happens when values change. Maybe they've made a misreading and they need to correct it, whatever happens. So we know from 100 values set, the median is 90, mean is 95. They're going to increase the highest value in the data by 200. That's changing only the very top value. So now we need to work out what the median and mean are. So I'm going to do a quick diagram with it, where if we were to do the median first, the median of 100 numbers, you get 50 either side, so there's 50 numbers here, 50 numbers on the other side, and the median is right between the two. All they're saying here is this last number, the biggest value, is going to be increased by 200. That hasn't changed what this median is, it's stayed in the same place, so the median is unchanged. So the median does not change by changing this value. The only way the median changes is if either of these two values change, or in such a way that they don't move out way as well. So now let's work out what happens with the mean. Well, when we have mean, we calculate it from the sum of all values divided by the number of values. And in this case we're saying 95 is equal to the sum divided by 100. So we now know the sum is equal to 9,500. Multiply up. We come along and we're going to take the last number and just add 200 to it. So the new sum is 9,500. The one there just means another sum. We add 200 to it, it gives me 9,700. And when I do the mean now, it is the sum is 9,700 divided by, there are still only 100 values because we changed one, we did not add a new value to it. So divide that by 100 and now the mean is 97. Move on to the next question. This is a construction question. Now, particularly for internal exams, it's quite possible that in a construction question and they give you certain lengths, what might happen is the photocopier may change the length of those. So it's unlikely in any form you use these that when you do print them out that this line will be 8 centimetres or this line will be 10 centimetres. They're normally different by a little bit. If we change the size of the paper, it can be quite significant. You have a choice of two things to get full mark for this. You either use the lines as given, and that's what I'm going to do, or you have to go away and you'd use the correct measurements. But you cannot do both. Okay? So we're going to do this construction. I'm going to do it on the geometry software that I use. I have two lines and you'll see they are not actually set up as being 8 centimetres and 10 centimetres because on this software I wouldn't be able to fit the rhombus on. So have a quick look back. So I've got mine set at 4 and 5. I haven't got space to use 8 and 10 to create this rhombus. I'll be a long way off the page. So I'm going to use the lengths and use compasses to do it. Okay, and what it's saying I must do is I must construct a rhombus where the sides are 8 and the diagonal is 10. Now the way to construct this one is it's a construction of a triangle. Well, I know 3 sides of the triangle. These two are 8 and that side's 10. So I'm going to construct this triangle first. Put the base side in for 8, do another one at 8 and then do an arc to find the 8, do an arc saying this is 10, where those two cross will be the top apex of that triangle. So I need to set my compass here. First of all, draw a line. draw a line, and this one is any length at the moment. I'm going to set my compasses to my 8 centimetre line, which is the upper one. Set my compasses to 8 on my diagram for the exam question. On my actual working, it's only a 4 centimetre, and I make sure I've got that side. The second side is going to be another one, which is supposed to be 8 centimetres, and I've also got some side here which is also supposed to be an 8. Now I'm not going to draw that one in yet because I'm going to do the 10 as well. So the diagonal of my rhombus is 10 centimetres, so I'm going to use the lines they gave me, go and set my side correct, rotate where those two cross. They barely cross, so I'm going to check that arc back again. It's sort of useful because if I can get this to line up, it'd set it up for the second part of the construction. So there's my 2 8 sides, and that gives me 1 8 side, second 8 side, and there's the diagonal of 10. Having got that, I can now do the other top sides of my rhombus. I can now do these two sides, which are both 8s. So I come round. I think the point apex is going to be somewhere there, and off the end of that one, construct down. And now all I have to do is draw in my rhombus. So from that point to there is 8. From that point to there is 8. That point there to there is 8. That point from there to there is 8. And this diagonal should be my 10, which in my case will be a 5. I'm pretty certain that's going to be the case because I used the compasses to set it. So that is how I can complete that construction. Okay, so moving on to the next question. Question number 24. This question's a little bit complicated. It is a level 8 question. It's a form of proof. And what we've got to show is that A and B that meets these requirements cannot be a whole integer. And integers, remember, whole numbers. Okay. Need to use an algebraic technique. So we're going to first write out the sum of these two things is A plus B, and the product is A times B. That's what product means, and they are equal. So now I've got A's and B's in both places. You might be tempted to try and cancel things. It won't really work. So there's one equation, and we've got a second equation given to us by their definition of what A and B are relative to each other. So there's my system of equations. To solve this technique, you could do a manipulation and arrange, but you're never going to get rid of the another letter. So we're going to do it by substitution. Okay, so in this case, I'm going to put, instead of A, I'm going to put B plus 2 into, so we're going to put equation 2 into equation 1. So instead of A, I've got B plus 2 plus a B is equal to, and we also need to put, instead of the A on this side, a B plus 2, and we're going to multiply that by B. What we need to remember though is A, we are replacing with B plus 2, which is, because they're not high enough order, if you hadn't put the bracket around it, it wouldn't do the addition correctly. Simplify both sides, so 2B plus 2 is equal to B squared plus 2B. Rearrange to bring everything onto the same side, and now we're actually going to solve a quadratic from this point onwards. So we're going to do a quadratic solution. Rearrange the equation. The b's cancel. So, sorry, take the 2b to that side, minus 2b, minus 2. 2b's cancel, so I'm left with b squared minus 2 is equal to 0. This is a special form of quadratic solution that, because we don't have a beta, we can do this one by simple rearrangement. We don't have to factorise, we don't have to use the quadratic formula. So b squared is equal to 2, so b equals the square root of 2. And the square root of 2, all you need to know is this is not an integer. It's actually very special, and it can't even be written as a fraction. It's a number that continues forever without repetition. It's called irrational. So if b is irrational, we put it back into our equation for a. A is 2 plus b. That means it's 2 plus the square root of 2. And again, that's irrational. You can do nothing about combining these terms together, or anything that makes a better step. We've now shown that both a and b are irrational, hence we can say that we have not got integer solutions. Final question, number 25. Change the temperatures measured in degrees Celsius to Fahrenheit. We could use these formulae. This is the exact formula for a certain form of exact, but this is the most accurate formula people generally use, and this is a rough one that people use in their head just to get roughly convert between the two temperatures. Fahrenheit's the temperature scale used in America. Freezing point is at minus 32. Boiling point is about 212 degrees Fahrenheit, rather than 0 and 100. Reading through the question, we're not actually being asked to use this formula in any specific way, apart from saying at what temperature in degrees C does the formula give an equal value for f. Notice you must show an algebraic method. That means that you're not allowed to use trial and improvement, and you shouldn't try drawing graphs to solve it. So no trial and improvement, and no graph. You must use algebraic techniques. So what it's actually saying is these two formulae for a given at what temperature in degrees C do the f's match. So we're going to say this f is equal to this f, so therefore that formula equals that formula. And we've got solving an equation with a few nasty little tweaks of it being fractions in there as well. So we've got the exact formula is equal to the approximate formula, and we're into our usual rearrangements. 9 over 5 is smaller than 2c, so I'm going to subtract that from both sides. So now, having converted this, I can subtract 9/5 of c from that side. So 32 is equal to 10/5 of c minus 9/5 of c plus 30. That tells me I have 10 minus 9 is 1/5 of c, and if I take the 30 from both sides, I get 2 left. So therefore c equals, multiply both sides by 5 to give me 10 degrees C. What I should do at this point is quickly check. So if I check it, I can see if c is 10, I've got 9 over 5 times 10 plus 32. 90 over, cancel those two, we've got 18 plus 32 is 50 degrees Fahrenheit. And if I put it into the other side, we've got 2 times 10 plus 30, again 50 degrees Fahrenheit. So I've even checked my answer as well. Right, that's all those paper ones. I hope they're going well for you. and good luck with whatever exams you're doing.